Okay, so good afternoon, everyone, and welcome back to Study Express Academy. So, without wasting much time, in the next few seconds, we're going to be starting physics class. Okay, so as you all know from the flyer that was posted and reached out this week, we'll be continuing with the first concept under physics. So, we'll complete the first concept probably this week. Hopefully this time around, so that we're able to go to another subject next time. So our tutor is already here and is available to take the class. So just you guys, I want you to write, I'm ready. Okay, type I'm ready. I'm ready. I want you guys to type I'm ready. Okay, type I'm ready. If you're typing I'm ready, I want you to stay on the live session, and in the next few seconds, in less than a minute, we're going to start the class. So I'll be waiting for you guys to type and then to engage. So you can also share the link out to your colleagues, to your friends, or any other person you believe they are going to benefit, or they can influence people that will benefit from this also. So you can share the link out. And also don't forget to subscribe to our channel. So as you are here right now, you can just click the subscribe button beneath the video, and then so for every single time we have live sessions, and I'm telling you, it's not only going to be Sunday sessions anymore right now, because the exam periods are getting closer. The exam period is getting closer rather, and we have a lot of plan in place. So some of our physical classes which we take, we can always like do some impromptu videos whereby you meet some random videos online talking about some courses or some subjects. So that will be like some videos of our part of our life of our physical classes, and also some other arranged classes. And that's one of the main reasons why you should join the WhatsApp group. So like I've said, we have been checking our recent videos, and in fact this one probably you'll be seeing number that is going through the video, is going beneath the video. So the phone number is our official phone number, but you only type messages on WhatsApp for now. That's on WhatsApp. We basically send messages on WhatsApp to the Express account. So if you want to know more, if you want to ask for more inquiries, whether it's about our paid class, because we also have paid class. Yes, and I'll be advising you. In fact, I will implore you, I will strongly implore you that you join our paid class. Don't wait till any other time to join the paid class. I mean, this is the very best time. You don't have to wait till tomorrow anymore. Yes, there are a lot of things going on currently in the paid class, and there are a whole lot of benefits you're going to get apart from the free class itself. So, because I want so good for you, I think you should join as early as possible. If you can join today, just message message any other thing you want to know about the pricing, about the classes, about the timing, about the tutors, about the mock exam, and every other thing you need to know about. So for now, this is still weekly, and this one is free. You can always send it to anybody, but please, in what way can you help us out? You can help us out by doing what? By subscribing. Yes, by subscribing. So click on that subscribe button. Sincerely, we really want to reach thousands of people in this jam. Yes, we want to make sure that we achieve over 1,000 people on YouTube. I mean, for our subscription. So if you guys can really help us out with that, we know you can do it, and with your help, that's the only way we can do it. That's the only way we can do it. We cannot do it by ourselves. We can only do it by your help. Okay, so that's why you should invite people to join our classes. Let them subscribe. People that you know they're going to benefit. In fact, maybe they'll benefit in the long run. Let them still join. So it's not everything that's going to be paid. Definitely not. Everything I've been given so far is what is free. And also, I'll not limit it to YouTube alone. Beyond this YouTube platform, we have majority of other things that we do offline. Like we do brainstorming sessions on our WhatsApp platforms. Yes, we have different WhatsApp platforms for our brainstorming session. I mean groups. So if you join our groups, we used to do brainstorming session every night. Yes, we do brainstorming sessions every night. So we'll release it's a student community anyways. You ask questions, people would respond to questions. You ask questions, some people will answer the questions. You can also answer questions whereby your colleagues are also certain or they do not understand. You can give explanations to that thing. And then if any students on the online platform do not know the answer to the particular question asked, then there'll be intervention of the tutors, because there are always tutors readily available in real time to answer whatever questions you have in the brainstorming session. So we also recommend some materials, give some links to mock tests online for your for the brainstorming session, and that's one of the main reasons why you should never miss even the free class. So More inquiries, I think you should message the number on the screen and then we'll respond to you in real time. So lastly, before I proceed to call our tutor in, there's this project we are working on right now and it's going to be released tomorrow. Yes, it's going to be released tomorrow. So, and I strongly advise you to join our groups. In fact, most especially our channel, our WhatsApp channel. How will you get to know our WhatsApp channel? You can ask on the comment section. You can ask in the comment section. Our official account will use to respond to you. We'll send the link to you, or you type a WhatsApp message to the number you are seeing on the screen. You ask that, how do you join? You want to know more inquiries about the Study Express Academy. How do you join the WhatsApp channel, or what exactly I'm going to talk about right now? So what I'm going to talk about is that there's this plan. There's this plan that we've compressed, we have modified, and then into a PDF form, okay, a document format, yes, a portable document. So this PDF it contains what? It contains a step-by-step blueprint. I mean, a step-by-step plan on how you can achieve the best possible grade in your UTME, in your JAM. So this thing is like, okay, I want to get 360 in my jam, I want to get 370, I want to get above 300, or basically your problem is with my current capability, do I think I can get a very high score in jam, in UTME? The answer is yes, 100% yes. You can optimize the use of the knowledge you have right now. In fact, some people, just with this blueprint, it has worked for many students, a whole lot of students. And most of the time, you see the students in the 250 range, 250 UTME score range to 300 UTME score range, they are always just a little bit, maybe just tactics also. So this PDF is like a step-by-step format where it's, in fact, it is daily. Yes, so it will tell you, like it will give you suggestions on what you can do best to achieve your best possible score. Yes. So if you want to know about that, message the Study Express account, or if you're on the group already, I would implore you, we'll send our WhatsApp channel link again today because it will only be released on the WhatsApp channel link. Yes, and exclusively for the WhatsApp channel because we want to grow our WhatsApp channel. So we'll be sending the link there. So if you have any, because the WhatsApp channel is general, so you can go there, subscribe. Yes, just follow us on the WhatsApp channel. Once you follow us on our WhatsApp channel, we'll release the link for the PDF. Okay, so that PDF is going to tell you the step by step of everything you need, how to work on the, your difficult subjects, your difficult topics, how to optimize your scores, how to answer questions efficiently in your UTME. Okay, and I look forward to you guys joining us in our next course. So thank you very much. Now our visitor will be entering, and I hope you guys are still there. Don't forget to subscribe. Go back there and subscribe. Okay. Subscribe. Yes. So our tutor will be entering now.
Hi everyone, welcome to Study Express Academy. So today we shall be taking force concept. So okay, I'm going to take you on how to solve some problem on forces regarding your jam or why collectively based on exam possible question they can ask you on what on force regarding any exam all level. You understand? So generally, germ, work. So that's going to be their focus on how to solve problem regarding this. So in summary, all basic things you need. First one, last class we did one by nature force of motion, and that let us know that how what force is entire, what force it is, and the formula for force. So, what are basic summary? First one, we all know what the formula for force is. So, what does the definition basically show? So this will let you know that your force represented by F, and A is the acceleration, while M is the mass of the object. So what does force cause? So your force is an agent that change the position of mass of a body. May it change the position of a mass. May make a mass to what? To accelerate. So for a mass to accelerate, there must be an action of what? Of force. So the direction of acceleration of this mass is the direction of the applied force. So the how fast the mass move or changes or accelerates depend on the action of force. So the purpose of this arrow shows what we have there, the direction of mass of the object of the escalator. Very simple. So take note of that. And this changes the position of the object, meaning the object is not in equilibrium. When an object is in equilibrium, what's going to happen? It means that the acceleration of the object will be equal to zero. So the other condition was to take is if this acceleration of the mass of these objects, you know that the mass of the object will be constant. So if the acceleration is equal to zero, that's also what was to take last class. So if A is equal to zero, what does that imply? Get what? It means the what we have here. So A is zero times the mass of the object, which is constant. Every object has its what? Its mass. So that's what your mass is constant. So that's meaning. So what's gonna be the first then? So the second one is our F will be equals to what? Will be equals to zero. Please note this. So that's it. So our F is gonna equals to zero. So the all sum of forces acting on the body will be equals to what we have will be equals to zero, when A is equals to zero. And what are the conditions for A to be equals to zero? Don't forget in our last class, what are the conditions, meaning if the object is at rest. You understand? If object is at rest, meaning no force is acting on it. So acceleration is equal to zero. Or what other condition for a body to be for a body to have an acceleration equals to zero? So that if the body is moving to a constant velocity. So if a body is moving at a constant velocity, so it's a motion, not at rest anymore. So if the velocity of the object is constant, that's the meaning. If the velocity of the object is constant, so what's going to happen is acceleration is also equal to zero. And the force acting on it is equal to what? Is equal to zero. And actually, if all the sum of forces acting on the body is zero, it means that the body is what? Is at equilibrium position. So it's at equilibrium position. And that's very clear. Don't forget that, please. For the acceleration to be equal to zero, what are the two conditions? So the two conditions for this. So, okay, let me just make it like this. So we have, so at rest, everybody is moving with constant velocity in a straight line. So this is going to result to. So these two things are very important. Likewise, also about friction. What friction does? We've known what force. Force causes what the position of bodies to change, set a mass into acceleration. So unbalanced force acting on the body changes its position. So that's the meaning. So if force accelerates or if force causes motion, so what opposes motion? So if the mass of the object is accelerating, guess what? If the mass of the object is accelerating, let's say I have a floor, so this is a floor, and I kick this ball, so what's going to happen with the force and its mass? So it's going to accelerate in this direction, and I'll be having the body moving. Can you see? Moving, but it's going to later stop. So definitely there's what opposes. There's what opposes what the motion of this object. So what opposes the motion, we call that what? Our frictional force. So what do you think about friction? So we call it solid friction, mind you. So you can have liquid friction, we have a solid friction. So what are friction causes? So force causes what? Motion, that is the mass of the body to accelerate. So the body begins to move in this direction, but it's what? It later stop. So it's going to stop. Let's say stop. So what brought this mass to stop is what we have is what called a friction. You understand? So the friction opposes what we have motion. And what type of friction did I call this? I call it solid friction. So there are two types of solid friction. So we know what friction is. Do you understand? Actually, friction acts, do you understand, between between surface of two bodies in contact. But it's come to play when a body is in what? It's is in motion. How does it play? It opposes the motion of the body. You understand? Which causes the water to stop. And in our last class, What's explain your for your body to move? You understand? For body to respond towards to force, what must happen? Step one, it need to overcome what they have the frictional force. We call you frictional force for solid friction. We have the static and we have the kinetic. So the static is one that opposes the applied force, which increases as the applied force also what increases. So that's what static friction. So our last class we'll talk about what also talk about the static friction. So that become Fs. So your static friction. So this come to play. Do you understand? When a force is applied on an object, no. If the applied force is equal to zero, do you understand? So the bodies are static. But if I begin to drag the body, if I begin to pull the body towards myself, what did I imagine? I'm going to imagine the body to move along the force which I apply. It needs to move along the force which I apply, but it needs to overcome what? It needs to overcome the static friction before the body starts what to accelerate. So that would say friction opposes what we have a motion. So we also talk about we have to like we have two friction. We have the static and so we have that of the kinetic. So what is static? I've told you that when a body is what is at rest or it's about to move on its surface. So that's for static. The less that means the applied force is weak. The equals to means what we have the body is about what is about to move, and that point is called limiting what friction. Meaning the static friction as reaches what the maximum first before the body begins to slide on the surface. So that will call your limiting what friction. So therefore, what I'm going to so therefore I'll be having what equals to. But what is that less than? Less than means what they have the applied force is weak. Do you understand? So that means of less than. Now, what if the body now begins to move? Do you understand? The body begins to slide on the surface. So what force do you think that comes to play since the body is in motion then? So we call that word kinetic what? Kinetic friction. So kinetic means the body is in motion. So the kinetic friction comes to play when the body is what is in motion. Oh, that's clear. And this is why actually the first cause is don't forget, first cause the mass will accelerate. Kinetic friction will come into play when a body is in what is in motion. And what does friction cause? Number one, it opposes the motion of an object. And don't forget, it is direct proportional to the reaction, to the reactional force exerted by the surface. I hope that is clear. And don't forget, we know what these things stand for. It depends on the nature of the surface in contact, but not the area. Nature. All materials in which a body slide or move on has its own coefficient of friction. It's called coefficient of static friction. It's called coefficient of kinetic friction. All substances what has, and they will call it lets us to know how a body responds to what to friction. Do you understand? If it is on a smooth horizontal surface, do you understand whether the smooth horizontal surface or if it's not rough surface. Thank you. Now, how did I apply all these things that's on board? Now, let's get to say. Ready? Let's start. And I'm going to throw the question to you. So, if I have now, yeah, this is surface, and let's replace mass. So, do you see? So, I want to drag this body on this surface with whatever with a rope. So, I want to drag this on this surface with whatever place with a rope. So, and what do you call the force in a rope? So, we call the force in a rope, we call it what? The tensional force. You understand? So, I want to drag or pull. Do you understand? Pull this mass. Do you understand? By a rope or a cord. Do you understand? So, what do you call the force in a rope? We call it tension. So, that's why I written that word with C. But there's an angle. You get what? There's an angle which this tension is to the horizontal. There's an angle to which this tension, you understand, is what is inclined which also parallel to the surface. Can you see? It's parallel to the surface. So the broken line means whatever the tension units has an angle towards which is inclined. Just like you having someone like this on the surface, and let's say this is my diagram. So let me have a man here. So okay, let me make this man to be more tall. So the man is trying to drag this. So it's trying to drag this on this surface. So it's moving towards this direction. So it's moving towards this direction and it's dragging this mass with this what with this rope. What's gonna happen to the mass? The mass will also accelerate in this direction in which what is dragging on. So it's pulling this, it's pulling it towards itself. So as the man is pulling this mass towards itself, so it can also accelerate in the direction of this mass. So if that is clear, that's what I'm trying to say. So now let's take a question. Let's see how I'm going to interpret this. Let's say, okay, the mass of this object is what is, like I said, the mass of this object is 2 kg. You get, and I apply the intentional force of 10 Newton. Do you understand? And I showed you this tensional force have an angle towards which it is what it is inclined. Do you understand? But what is the nature of the surface? Ask yourself. Is it a frictionless surface? Do you understand? Or the surface whatever is a rough surface? A smooth surface is frictionless. Get that right. Why whatever a rough surface has whatever has friction? So definitely the acceleration of the object will be opposed. Do you understand? There will always be the effect if the surface were to be rough. Compare the effect of friction. Compare if the surface of the surface is smooth. So if the surface is smooth, I experience whatever I experience no or less frictional force. But if the surface is rough, come on, what is surface is rough? No, that your force that you're acting on will also be against the frictional force because your friction opposes your motion. Do you understand? So if the surface is rough, come on, you're gonna have a lot to do more work to overcome the frictional force. Why? The surface is rough. So note that. So now let's solve this question. So how do we play with this question? Okay. So let's say this mass. Okay, this is 30-degree Newton, and apply the force of 2 Newton on a mass to drag what mass on this surface to drag a mass of 1 kg. So now, how do that? Now, yeah, there's something which I want to teach you. I want to teach you how to solve whatever some problem you face. So what do? Just draw the free body diagram. So what are the other forces acting on this force? So I'm going to draw the free body diagram on the let me do that. So I'm going to draw the free body diagram in order to see the forces acting on this. So ready? So let's see what are the free body diagram for this. So we have mass. Now, so what are the forces acting? So what are you? Actually, free body diagram is very important. Why solving what? Why solving forces? Let's say free body diagram. You should be able to show the forces acting on the mass. So what are the forces? Since I want to put this mass, what are the other forces which are acting on it? So ready? Let's go there. So the first one you need to know is mind me. So I need to show you this diagram. It's very important. You exactly understand what I'm doing. Now check. Do you see? So from the free body diagram shows that what? So this mass, so these are mass here, which is 1 kg. What are the forces acting on it? So I have 1, 2, 3, apart from my tensional force. Apart from my tensional force, which is what? Which is 2 Newton. And inclined at what angle? At whatever 30-degree. Oh, that's clear. So that one is represented with what? With blue marker. Am I good to go? Oh, fine. So let me put that as a tensional force T. Are you ready? So what now? If you look at tensional force, it's inclined at an angle what? 30 degrees to the horizontal. So if that is clear, what are the components of these forces? Component of the force, like I showed you last class, you need to understand component of forces. That is, if a force or a vector, you understand, when two vector acting on a body, know that the magnitude and direction can be represented by what? By two sides of a triangle taken in order. But the resultant acts in opposite direction. Coming from what we have here? Coming from the common point. So what's going to be the common point? So this is the common point. What are other two forces that can be acting, which they are component of what? Of your tension at T. So component of forces, very simple. Don't be disturbed. A component of force means the force that is acting component on the vertical component and what they have the horizontal component. If you don't understand what component means, axis, your y-axis and your x-axis. So therefore, what's going to be tensional force acting what? The tensional force acting vertically. So that one is what we have. We call that T. Why? Why the one acting what horizontally? So we call that what? Tx. So we call that Tx. Why? The one acting what vertically is called what? Ty. So your 2y and Tx represent the components of force, of tensional force. T. Do you understand? So not that. Oh, that is clear. Now let's now come here. So what are the two other forces? The three other forces? Can you see the arrow? You need to show the arrow. You know it's a vector. So this is, guess what? Wait. So which one is going to oppose the motion? You want to oppose the motion because the direction, the direction of acceleration of the body, mind you, is towards this. The body is going to accelerate towards this direction. So that's going to be this direction of the acceleration if the mass is pulled by a tensional force of 2 Newton. And how will it accelerate? It's going to accelerate what they have horizontally. So that means of x. So x means what? Horizontal acceleration, because it's going to accelerate horizontally. So now let's go. What other? So if accelerate horizontally, so these are direction of motion. So direction of what? Motion, that is acceleration. Now, so we're gonna oppose. So we're gonna oppose this is our frictional force. So our frictional force. Now the other one here we have our reactional force, which is what? Which is our R. So those are the three other forces. So your weight, which acts what you have it, which acts downward, and what opposes your weight is called your reactional force. A reactional force come into play when a body is about to move over the surface. That is, the surface itself also reacts. Yes, by exerting what? A force on the mass, and I'll call your normal reactional what? Force. So that's it. Your friction opposes the motion. Your frictional force is the force exerted by the surface on this mass, while the weight of the object acts whatever it acts downward. Now let's go to play, please. So what's going to be our Tx? What's going to be our Ty? We need to get the component of both of these forces. Why? Because the tension is inclined at an angle. And what's the angle? 30 degrees. So how do we do that? So we do that by working using what? Triangular of vector. From the triangular of vector, put these three vectors. 1, 2, and the resultant of these two. Put them into what? Triangle. That we call triangular of vector. You understand? Just put them into a triangle. I'm going to put into that triangle. So that's very, very simple. So that's very, very, very simple. So just draw your triangle. That's meaning. Just draw your triangle towards this. So make it a triangle. So I'll just come here. So that's it. So I've made what we have the triangle. So that's called triangle of what? Of vector. And mind you, so what do you have it? Come here. So your Ty is parallel to this side. So this is gonna be your Ty. So parallel. So they are both what you have it? Parallel. and your tx. So this is your tx. So let me to draw that very well. So this is your tx. So your tx. So I've put them into what we have into a triangle. Mind you, look at the arrow. They are in what? So they are in what? In triangle. So that we call triangle of what vector. Actually, what's the direction of acceleration? So the direction of the acceleration of this mass is going to accelerate towards this direction. Horizontally. So now let's solve our answer. So we're going to be answer here. Now, so see the body accelerates what horizontally, and it is opposed by what friction as force F. So what do? Yeah, I want to teach you something. When a body is in motion, you take the side to be positive. So when it's in motion, you take the side to be positive. So that is the body in motion. Why opposite? Do you understand? So opposite to it. So the opposite to the motion. So the direction of that will look like this. You know, the opposite of this one, what's mean the opposite of this line and this other. So this is the opposite set. So the opposite. So ignore opposite is what the motion. Are you ready? So now since what direction of motion is what you have is our tx. So I'm going to put my tx positive. So I'm going to add all the horizontal forces together because the body is not at equilibrium. Since the body is not at equilibrium, so what am I going to apply? I'm going to apply Newton's second law of what you have 18 second law of motion. So since I'm applying Newton's second law of motion, let's play. So the resultant forces acting horizontally will now be equals to what? Equals to ma. So the body is not at equilibrium. So if the body is not at equilibrium, what does that imply? Meaning the body is accelerating. So definitely based on Newton's second motion, so the forces acting on it will be because of what? Ma. Now what are the horizontal forces? We have the tx. So let's add it. This symbol means summation. We should add all the forces together. So we have tx, so which is motion. And what is this? This opposes the motion. So that becomes plus our F, but oppose. So I put minus. This is plus. So I'm going to put minus here. Equals to what do you have here, guys? So that's it. So we're going to be a final answer. This and this. I have what do you have here? The Tx minus what? My frictional force equals mass times what? Acceleration. I hope that is clear. So what the purpose of positive and negative? So the purpose of positive and negative is what? Motion, opposition to the what? To the motion. Add the forces together, and I get what? And I get this. So working on my Tx. Your Tx is the adjacent. And what's your adjacent? You should know your what? Simple geometry. So your simple geometry, so you all know that your so in the Katwa. So for so Katwa, so in the case here, so we're gonna be the opposite, so you just cross multiply. So opposite going to be the opposite of a side will be hypotenuse sine theta. Why the adjacent of a side just cross multiply. So the adjacent of a side, the adjacent of an angle will be the hypotenuse of the angle times what? The cos of the angle. But the opposite of an angle, the opposite of an angle will be the hypotenuse cross and multiply it. So will be the hypotenuse sine times sine of the angle. So come here. We're going to be our Tx. So our Tx is the adjacent. So far is the adjacent. So we're going to be our answer. That's going to be the hypotenuse. What's the hypotenuse? Which is our T. How that is clear. T, that's our hypotenuse. This is your hypotenuse. Mind you? This is our hypotenuse. So cross and multiply. Times the cos of the angle. So that becomes what do you have? Cos of the angle. What's the angle? So 30 degrees. So let me just write theta. Minus, what's our frictional force? So here saying the body is moving. So this in the body is what do you have is moving. So in this case, we can have that to be. Oh, now in this question, they need to give you the coefficient of what of friction of this surface, or the frictional, the static, the coefficient of friction. So if they give us coefficient of friction, we can easily calculate. But let's just say of a frictional force of, let's give a frictional force of 2 Newton. But let me just still give you that. So now, what are friction? We know our friction, but what friction will this be? The friction are going to be is going to be what they have your kinetic friction, and what do you have R equals to what do you have, you guys? So these are your expression will look like. So these are your expression will look like. I told you this is going to be your kinetic. Why kinetic? Because the body is in what? Is in acceleration. So that's it. The body is in acceleration. So these are going to look like. So now, come on. Get to know now. Let's see. What's our tension? Our tension is 2 Newton cos of what? Of the angle. So 2 Newton cos of the angle. So what's the angle? 30 degree minus. What's the coefficient of what? The coefficient of friction of this surface? Actually, I didn't mention that to you. Do you understand? So let's take that to be 0.2. You understand? So let's take that to be 0.2. So I'm going to be having that to be whatever is 0.2 times we're going to be equal to our R. Now, yeah, your R during some balances what we have the weight, why the whole body move what horizontally. So since your R balances the weight, so here what am I going to write? So write this as what mg. Do you understand? That become mu what do you have it? Mg. That is the mass and what and the gravity. Hope that is clear. So I can also write this as what as mu mg because here the R balances the weight as the body or as the body oscillates what horizontally. So what I'm going to get here, so I can write this one as mg as what your heart balances the weight here as body move horizontally, so that become mg. Do you understand that? So and where did I get that from? I told you the body is moving whatever it's moving horizontally. So here I'll be having my heart equals our weight, and what's the weight, everyone? So our weight is equals to mg. So now what's the mass? Yeah, let's go. The mass is 1. Let me put this into brackets. So the mass is 1 kg times the gravity, so 10 equals what do you have? So the mass, that is 1 times what the acceleration. So the horizontal acceleration, and we get our answer. Oh, that's clear? So we get our answer. So we're going to be have, so we're going to be 2 cos 30. Do you understand? So you multiply this. So this is making what? 1.7 what? So if you calculate that, so it's 0.2 times what that times 10. So what are going to have? So right? Oh, this value is going to be too much. So now let's go equals. So 1 times a, so we get. So and we subtract 1. So what do you have? So actually, why is this acceleration negative? It shows that after some time the body is coming towards to rest. So this is called what? Retardation. Do you understand? Retardation of what we have of a body moving in an horizontal what surface. Retardation of a body moving on horizontal what we have moving on horizontal surface. So now I want to show you something. Now let's take these following cases and let's play with them. Ready? Now let's go. So showing the following cases. Okay. So this you really need this a lot. So after I'm done with this, I also explain some connected bodies. That is clear. So I'll explain some connected bodies. Mind you, sorry, before I move on, I want to show you something. For this, a single body on an horizontal surface. On an horizontal surface. Are you there? So what if this surface is frictionless? You know what I mean? If the first surface is what is frictionless. So if surface is frictionless, you know what that's going to give us? So if the surface of this body is frictionless, it means that what? The coefficient of friction will be equals the coefficient of friction will be equal to zero. So if that coefficient of friction is equal to zero, so if you put here is there, so if the coefficient of friction is equal to zero, what's going to be your frictional force? So frictional force is equal to zero. Therefore, this will bring about what? The horizontal. So the horizontal tensional force will be equal to what? The mass and the horizontal acceleration which the body is moving with. And therefore, here you can easily calculate what the horizontal acceleration of the body. Hope that is clear. That is, if body is what if it is frictionless. Do you understand? So frictionless horizontal surface, or the body is moving with what is moving on a smooth horizontal what horizontal surface. Now, let's see if we also have this. Okay, let me draw. So here I have mass m. So I have what I say. I have a mass and it's inclined at an angle. So this is angle of inclination. So let's put this is what? Theta. So and our theta represents what the angle of inclination. So what do you think is going to happen to the body? So let's just be fast. So mind you, so let me raise the mass up a bit. So because I want to add some things together with it rather than duplicating our effort. So let me just put it somewhere here. So good one. Yeah, let's go there. So this is a block. So this block is placed on an inclined plane. So your theta is representing what the angle of inclination of the plane. So what do you think is going to happen to this mass? So this mass is going to accelerate. What do you have? It's going to accelerate down the plane. So what do you call this one? This is also called what? Acceleration of the body down the plane. So how do you treat this kind of question? So the first one, it says that the direction of acceleration of the body is. So the direction of acceleration of the body is, so the body is going to accelerate toward the other downward. So what's going to be the acceleration down the plane? And you can also up what's going to be the minimum acceleration up the plane. So let's get what the acceleration down the plane. If it is inclined at an angle at an angle of theta. So what I do actually just do what your free body diagram showing the forces acting on this body. I want to go. So what would that be? So let's show that. So the first one, you draw your weight. So, sorry. So the weight of the body acts downward. So you draw that. So that's the weight of the body acting what you have acting the weight of this mass. So acting downward. The second one is called what they have the reactional force. So what's going to be the reactional force? So the reactional force, this is your R representing what? The reactional force. So that's the normal reactional force. Now, actually, that body here is going to slide down what they have down the surface. So what's going to be the force which bring it down the surface? So let's show that here. So the force that bring this down the surface. So here means what? The force that bring the body what down the surface. This direction of the acceleration. So the question is, what is the force? So this is the direction of the acceleration. So the question is what is the minimum force that bring the body down the surface? And here we'll be having our friction, which opposes the what? Our friction is going to oppose this. So you put your friction, and your friction is always parallel to the surface. So let me put it on the surface. It's parallel to the surface. So I'm going to put that towards the surface. So it's parallel to the surface. So here so have to be my frictional force. So F, that's the frictional force. It's always parallel to the surface. So if all that is clear. Now from here, so what going to be the component of your weight? Don't forget, so what going to be the component of your weight? So we put the weight into what? Into its various components. And you draw that. You're going to draw the Y and X axis of the weight. So what's going to be the Y and X axis of the weight? I'm going to use the blue marker. So this is the Y axis of the weight. And what is the x-axis of the weight? So we take this surface here as the x-axis of the weight. So our surface here is the x-axis of what? Of the weight. Hope that is clear. So in this case, so we have, this is the x, y, this is what? The y. So we're going to be the horizontal component of the weight. So this become what? Your wx, y. This is going to be what? W what? Y. So that's me know the component of the weight. How that is clear. So if this is theta, so the angle here will also be what? Will also be theta. So very simple. We've explained that last class. Now put this into what? Into, so let's put it into, so those are the components of what? Of the weight. So if it's x component of the weight, meaning put the weight into y and x axis. So what do? You see the way I use the blue marker to show. So this is the y-axis, this is the x-axis, and I write what? Wy, and where I write wx. Now I actually put it into what they have a triangle, like I explained here. So put it into what? Triangle. So if I pull this into triangle, I'll draw it like this. So we'll be having, you should have something like this. So let me make it this for you. So you have something like this. So this line here is parallel to wx. So it's parallel to wx. So it's parallel to wx. Oh, that is clear. So it's parallel to wx. And this is your wy. But you have your wy here. So this wy and this is at a right angle to each other. So that's at a right angle to each other. Now let's go there. So very simple. Now let's calculate our acceleration and let's calculate what we have our force. So how that is clear. So since the body is sliding, check the direction of motion. Since the body is moving down, so your frictional force will oppose it. This is the minimum force bringing the body down the world, down the surface. How that is clear. And what's going to be your wx? So from here, the angle theta, your wx is the opposite, while wy is what? Is adjacent. Hope that is clear. So let's write those 10 down. So here our wx is the opposite. So since the wx is the opposite, so let me put that here for you. So that since that is the opposite. So what did I call the opposite of an angle? The opposite of an angle is going to be the hypotenuse, and it cross and multiply to the sine of the angle. So that's going to be the hypotenuse. So what's the hypotenuse? Is the weight, which is acting what? Which is acting down. So that becomes your weight. And what's your weight? Your weight is what? Mg. So add mg. What else I have? Sine theta. So that's the opposite, and actually your wy is the adjacent. So actually I don't know that. So this is equals to what? Okay, that's your your wx. Which other force? Now come here. What are the forces? You know, I have the I have my F, which is my force. I have my your wx. But note, since the body is accelerating down the surface, the body is accelerating down the surface. I want to calculate what? The acceleration of this body. What will be the acceleration of the body down the surface? So let's add all the forces acting horizontally. So to get the force acting down, so all right. Okay, come here, please. And if I forget that for you, so what will be your wy? Your wy is what? Is the adjacent, and that becomes what? Mg cos theta. So that one is the adjacent. Now let's go. Ready? So I have the opposite. This is opposition. Why? This is what? Motion. So your wx is the motion. So that is plus. Oh, let me, before I move forward, I want to calculate the acceleration which the body is moving with. So since I want to calculate the acceleration which the body is moving, so what did I write? So I add all the forces acting what horizontally. So I'm going to add all the forces acting horizontally. So all the sum of forces acting horizontally is equal to the mass based on Newton's second law of motion. So it's equal to the mass times what? The horizontal acceleration. Ready? So let's go. What are all the forces acting horizontally? So I have the Wx. So please keep this aside. I have the what? The Wx. So I write Wx. So which set the body into what? Into motion. Plus, what do you have? What opposes this? So I put minus. Oppose is our frictional force, which is equals what do you have here, you guys? So I think now let's go. So what's the W is your what do you have this? Your mx. So your mx, your wx. So I write wx. That is the horizontal weight. Yeah, and the plus times minus. So I have minus. My frictional force equals. Oh, that is clear. I think it's very nice, simple. Now let's go. So what they write as this. So this become mg sine theta minus, what do you have? You know, this is going to set into what? Kinetic friction. So kinetic friction. So I'm going to be having coefficient of kinetic friction and R equals what I have here equals ma. And don't forget, I showed you since the body now. Your reactional force always oppose what you have there, like it's in opposite direction to the weight. So from here, and which one of the weight, which one is it in opposite direction to? Is the reactional force? So it's in opposite direction to what? To this what? To the weight. And when the body is in acceleration, so the both of them are equal. So from here, I can easily get that my R is equals to what? Your Wy. And what's Wy? Your Wy, I've told you here, from here is what? Mg what? Cos theta. So from here, yeah, put it there. And when put there, something's going to come on, which is the mass. So factorize the mass. So you'll be having what? Yeah. So you have mj sine theta minus. So you have the coefficient of kinetic friction. So you have mg cos of theta. So you can easily factorize out your mass. So you factorize your mass. So I'll be having mass into bracket g sine theta and I have, oh sorry, I can factorize mg. I can factorize out mg. Mg is coming here. Mg is coming here. So factorize out your mg. So we have mg, and you already have a cos theta equals m. So what's gonna happen? So mass, we cancel what? Mass. So the horizontal acceleration of the body from here is gonna be equals to what? Have you seen it? So the horizontal acceleration of this body will be equals to what? So the horizontal acceleration of this body will be equals g sine, what do we have? Theta minus the coefficient of friction, kinetic, mind you, cos what? Theta. Actually, it may also be, yeah, so equals, so they're going to give you equals what? Equals a horizontal. So this is going to be, oh, sorry, put it in brackets. So that's going to be g open bracket sine theta, g open bracket sine. So this is the acceleration of the body down the wall. They have the horizontal acceleration of the body down the surface, down the inclined wall. They have down the inclined plane. But what if that's what's going to be the minimum force? You don't need to disturb yourself. Since this is the acceleration, what's going to be the minimum force? So when you know the acceleration, just multiply to the mass, you get what? The minimum force to bring the body down the surface. So this is acceleration. And that is for what you have for what type of surface? For what type of surface is this one? For what you have for a rough surface. What if the surface is smooth? Guess what? If the surface is smooth, actually it's frictionless. It's frictionless. Do you understand? So if the surface is smooth, so what I showed you from there, I showed you for a smooth surface, the coefficient of friction is equal to what? 0. So put 0 here, back. What am I going to have? So therefore, this is going to be what? The acceleration, therefore, of the body will be what? G sine theta. So that is down the surface. So down the inclined plane, Do you understand? So down the inclined plane, I'll be having what you have it. The acceleration is body to be equals to this. I hope that is clear. Oh, come here. This is for tensional force. What if it's not for tensional force? Like I'm not using a tension. I'm just ordinarily using what we have it. The body just accelerates horizontally, meaning I use a pull force. Mind I just okay, let me do and I need all this. So let's in it and let me show you something. Okay. Is this so you need to know this one compared to that and see if I have this and I have the body accelerate towards this direction. So I have the body accelerate towards what towards this direction. So this implies that so this is the force F. So towards this direction. So that's gonna be my horizontal what my horizontal acceleration. So from here, what's gonna be well, what's gonna be equals to our force? So from here, your force is gonna be equals to the mass times what? Times the horizontal acceleration. But if the body, I told you is moving with what we have. You see, in the body, this force set the body into what? Into an horizontal acceleration. Therefore, what does that imply? Guess what? So yeah, that is going to be equals to what we have. This will be equals to your kinetic sliding over the surface. So the frictional force that will come to play to oppose the motion of this, which capable to oppose the motion of this, is called kinetic friction. So it's called what you have a kinetic friction to oppose the motion. This is the motion. This is opposition to what? To the what? To the motion. It's called your kinetic friction. So which is equal to stop this from moving, equal to stop this force from what? From moving. Actually, this has set it into what? Acceleration. So the force needed to what? To oppose it, and yeah. So for a body in motion, it's called what? It's called your kinetic friction. And that's it. So from here, I can get, and I know what's going to be our R. So what's going to be R is, so we know your R equals. So our R is always equals to what? The weight of the object. As usual, I hope that is clear. So that will always act downward. So here, what I'm going to have, so I'll be having, so yeah, the mass we cancel what? The mass. So what's going to be the horizontal acceleration? So that's going to be the coefficient of kinetic friction and what? And G. So that's it. So that's going to be coefficient of kinetic friction, what? And what? And G. Hope that is clear. I hope you understand that. So the body is set into motion. So for it to come towards to come to stop. So to come to stop meaning to come to rest. So to come to stop, definitely what's going to be the in that case, therefore, your frictional force, your kinetic frictional force will be equals to what you have equals to the applied what? The applied force, and I get the acceleration to be equals to that. Now come here. Yeah, I just need to show you that so that you know the differences. This is horizontal, so this is surface. This is inclined plane. If a plane is inclined, we have an angle of inclination of a plane, which is theta. This one is just an horizontal surface. This one is an inclined plane. Hope that is clear. So your theta is what? The angle of inclined plane. So therefore, what's going to be that? So you have this to be equal to this. Now, don't forget, this one a minus. Minus means it's coming down the plane. What if it is to what? To move up the plane? Shortcut. You don't need to pass through all this stress. This is stressful. Just use plus here. So it's going to be plus. So that what it's going to be the plus. So I'll now be writing. So that is down. So down the plane. So what's going to be the down the plane? So I'll be having the acceleration will now become what? G into bracket sine theta. Just put plus. So that is down the plane. Minus is what? Sorry, up the plane. I want to put up here. Sorry, up the plane. So for the up the plane, so you put plus, and I put what we have a cos theta equals. So this is going to be your acceleration. I hope you know the difference. So if it is down the plane, that is this is down the plane down. So this is acceleration, horizontal acceleration down the plane. why this is going to be what the horizontal acceleration, what they have a up the plane. So, and what's going to happen to the force? Just since you know your what we have your acceleration, you always know that what your force will be equals to what our force will be equals F equals what they have and A. So that I can see what's going to be the force to bring the body down the plane. So you need to know the acceleration. And what's going to be the acceleration? So you use this. So if it is what you have a up the plane, so if it is up the plane, let me write that very well for you. So if it is up the plane, up the plane. So up the plane, just use what plus. And mind you, so I missed something off here. So don't forget your coefficient of friction. So you put that. So coefficient of friction, that is up the plane. So that's going to be the word, the force. So since you've gotten your acceleration, just multiply by to the mass, and you get your answer. You're going to see a lot of questions regarding this in your exam. So it's coming. So you're going to say that. But don't forget, it's frictionless. If the body is frictionless, what's going to be your mu? Or if they don't put frictionless just on a smooth surface, so your mu is going to be equal to what is 0. So what's going to be the acceleration? So therefore, your acceleration because what d sine theta. But this, I've told you the difference. I've explained this earlier for you. So you need to know what they have the difference. But mind you, you can always relate this on to motion. You can always listen to what I say to motion. Your equation of what? Motion. Your equation of motion. They can ask me, at what distance? At what distance does this mass move down this? At what distance? So you can also equate what? To motion. And that's going to be what? Ready? Now, get what? So they ask you, just like relating this what to motion. So, and the question will come in what way? It's going to be distance to time. Distance to time, very simple. So, and that will look like this. So, distance is equal. So, don't forget your UT plus what do you have? Plus half 80 squared. Don't mind my T look like plus. But let me put that now. Ready? Guess what? So if they are relating these words to motion, so what they ask you to calculate is what? Calculate the distance. You get what? So calculate distance. Either they give you the distance or they give you what? The time. So either way, so they always give you what you have. Either they give you the distance or they give you what? The time. Either they give you the time or the distance. But what's not going to be the acceleration? For you to be able to know the acceleration down the plane, so use your formula. So the acceleration down the plane would be what you have g into bracket sine theta minus mu cos theta. But if you're going to be the up the plane, so acceleration up the plane, so that's going to be what you have. So you use this. So now you just after you get the acceleration, you can easily calculate the distance, but they'll give you the time. Or they should give you what at the time you are told to look for what? The distance. But if you were to be a smooth surface, like the surface is what is very, 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 very smooth. So if you were to be a smooth surface and the body is coming, so if you're going to smooth surface, the body is not coming what? To rest. I mean, the body is coming to rest, something like this. So, and it's coming down. So it's coming down, so it's coming what? It's coming to rest. So in this case, we're going to be out. So it's coming down the plane. I can put what you have my initial velocity. So we're going to be my initial velocity. So your initial velocity will be equals to whatever is going to be equals to is 0. Do you understand what I'm trying to say? Let me come out again. I told you that if this body that have here, do you understand? Let's say this is a smooth surface. Actually, the surface is smooth. What's going to be the acceleration? Acceleration is going to be what? G sine theta. Never forget that. I hope that is clear. So if the body slide down, do you understand? But if it's going to be what? A smooth surface. So how would that look like? So what's going to be the initial velocity? So putting the initial velocity equals whatever is 0. A body is placed at the body is placed on an inclined plane. So what's the initial velocity? Is 0. Do you understand? So that's why it's equal to 0. And I'll be having s equals 1 over what we have at 2. But what's going to be the horizontal acceleration? If naturally the surface is smooth, let's assume that the surface is smooth. For a smooth surface, so I'll be having the acceleration to be what we have at g sine what we have at theta and what we have at c square actually this. So this is going to, how it's going to look like. That is clear. So if the body is placed on an inclined surface, do you understand? Hand was like on an inclined surface, and the surface is very, very smooth. Do you understand? Or on a frictionless surface and slide down. So at what distance has it covered all time? At what distance has it covered all time and on a condition frictionless? Do you understand? Frictionless or what? Or smooth. And to add it up, finally, which you're gonna see in your exam is add to this. Actually, if I drag this guy, normally it's gonna move through a distance. Now, come here. What has happened here? It's later come to what? To rest. And what make it what to come to rest? Like studio is what? It's friction. Well, that's clear. So you can be asked at what distance does it also what? Does it also move? Do you understand? So what they call this one? That is what they have a the stopping of the block due to friction. This is called the stopping of the block due to friction. We also have work done against friction. It asks what is work done against friction. You don't need to work. You don't need to do fast about that. It asks you what is work done against friction. That is very simple. So for work done against friction, that one is very simple. What's your work done? So my people, my work is force times what you have here times what the distance. And what's your force? Your force is mass times a times what you have here, the what the distance. And what do you think that is very essential that you need there? It's just only the acceleration. Mass is constant. They are going to give you the distance. So what's going to be the work done against friction? So if it's coming down the plane, your acceleration down the plane is going to be minus, like I bet this up the plane is going to be plus. It's going to be a smooth surface. Don't forget, if the surface is smooth, it will be because what g sine what theta. So it's only here that's very, 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 very essential in your formula. Very, very essential. So let me underline that for you. So what you just need to know here is very important is to know the acceleration, and these are the respective formula that you need for the acceleration. So let's hand it up here. So what stop the so to stopping of the block, so it has an initial velocity, and the velocity later stop, meaning the final velocity will be equals to what is zero, like its final what stop. So this is called retardation of the block. So the block comes to what later come to rest. Do you understand? And what will be the direction of the acceleration? So we have the direction of the acceleration here, like this. Oh, that is clear. So yeah, what do you use here? So you can give you a question like this as well. So what stop the body is what is due to friction. Do you understand? So this is called stopping of block by friction. So here you can calculate that becomes v squared equals u squared, and you know it's coming to rest. That becomes minus what do you have 2a s. Oh, that is clear. So what's going to be your v here? So your v is going to be equals to what is 0. So we have 0 squared. So don't waste time. So this is going to be equals to what is 0. Do you understand? It's coming to rest. Like so in that case, so I'll be having 0 equals let's go there, u square minus 2a whatever 2as. So from here we can easily calculate what the acceleration. So we're going to be our acceleration. So from here, so I'll be having 2as, which is the horizontal acceleration. The distance equals u squared. So your horizontal acceleration will be equals u squared divided by what? 2s. So u squared divided by what do you have here? So yeah. So you get what? U squared divided by 2s. And actually, yeah, do not forget what's up that is clear. So we'll be having the acceleration of the body will become what do you have here? So yeah, the acceleration of body, which is a, will be equals to what? U squared divided by what do you have here? Divided by 2s. And do not forget, from what I've told you the other time, so if body is moving, so what's going to be our acceleration here? So our acceleration is also equals to what do you have here? Mg. So if they ask you, calculate the coefficient of friction of this surface. Calculate the coefficient of this surface. So what did I write? Don't forget, since let's say look for the coefficient of the surface, I've told it here initially. So acceleration is also equal to what? The kinetic friction and what? And the gravity. So what's going to be your coefficient of the surface? So the coefficient of this surface will be equal to what you have a u squared all over what you have a 2gs. So that's going to be the coefficient of what? Of the surface. This acceleration. So we get this. So the going to be coefficient of the surface. Sorry. So let me write that for you very well. So this is going to be coefficient what of the surface. What if they link this one to momentum? So if they link it to momentum, and what do you understand by your momentum? A momentum of body, the momentum of the body is equal to what you have a mass times what you have a times the velocity. Don't forget the mass times what the velocity. So that will call what our momentum. So if they link this one to our momentum, so what I'm going to do? I'll just multiply this by what you have a by m multiply by what mass times velocity, mass times what we have a the velocity. So to momentum, I can also link that to momentum by saying this will be equal to what momentum all over. You know what I did here? I multiplied this by what? I multiplied this by velocity. So I'll be having mu times what do you have at u square? What do you have at you guys? 2g. So just multiply mu. So multiply by the mu. Multiply this one by also what mu. What are you going to have? So I'll be having so if multiply this by mu, also what? Multiply this by mu. So what do you think you're gonna have? So let me put square here, all square. Do you understand? So this also all square. So what are you gonna have? So I'll be having what they have a oh sorry. The mathematics is a bit wrong, sorry. So over. So what's your mu? That is mass times the velocity. What velocity? Initial velocity. So that's the momentum, and this is also what mass and what our velocity. Are we good to go? So now check. So if multiply, if since I have my u square here, so let me try to multiply this and this. So what do you think I'm going to have? I'll be having m u over what do you have? Oh, that is going to be too complex for you. So let me just do this for you. So u will cancel what u. Do you understand? So if you cancel u, I'm going to left to what do you have? U times this, I get what u square. Now, but let me make my mass to be m square and okay, let's make this to be m square. Oh, I hope that is clear. So hope this is not to be too much. Oh, I need to make my mathematics to be more simpler. Sorry, the say is somehow getting too much. So let me make this to be more simpler. So for us to convert this onto what momentum, so I want to make it what mu squared. So if I want to make it what mu squared, what is I'm going to do? I'm going to multiply both up and down by what you have a by what by so I multiply up and down by what mu squared. So now so that become mu square over what do you have a all square, please. Mu or what? All square times 2gs. So what are we gonna have here? You shall know your indices. They have the same base. So if they have the same base, what are we gonna have here, you guys? We have mu times what do you have here? U all square divided by, so multiply this and this together. So if you multiply this and this together, so you'll be having what do you have here? Mu and what do you have here? 2gs. So guess what? Here I have what do you have here? Mu square. So if I have mu square, I can easily bring out I can easily bring out my what? My u, one of the u out. So u we cancel what? U here. So what am I trying to say? So I'll be having be having mu square, something like this. So we'll be having mu square. So since I'm having mu square, so just bring one of the u out. If you bring one of the u out, you're gonna let u into brackets. I just want to make my mathematics more simpler. Do you understand? I hope that is clear. So I don't want to be too rushed, and so to make it more simpler. So if I multiply this and this, I'll be having what mu square. So bring one of the u out. So, and we shall be having what? U into brackets mu square all over, what do we have? Mu square with what do we have? 2g. So 2gs. So this we cancel this. Do you understand? We left what? U squared. So now let's go. What is our mu? Our mu is momentum. I just don't want to write the formula direct. I just need to show it. So our momentum is what we have. Our momentum is mu. And what do we left it? We are left it to what we have. We are left it to g. What do you have? M square. And u as cancel one of the u. One of the u are there. And that becomes what? U, which are initial velocity. And what do you have? An s, which are distance. So this is relation to what? To momentum. So relation to momentum. So you can also be given some words, something like this regarding to momentum. But they cannot give you far. They cannot give you far as this. But at times, just for some exam sake, they can link momentum. I can somehow from this. I'm going to link what coefficient of friction to momentum. So that's what we are just trying to what to basically show here. Do you understand? And sorry for the mathematics expression here. So we just need to make it more simpler so that you can easily understand that how this is clear. So what all the formula you need is for smooth surface. I'll explain surface. Acceleration is very important. So this is work done against friction. And if I ask to calculate the work done against friction, you see I did not write much. So calculate the work done against friction. So if I ask to calculate the work done against friction, what do you need is just the acceleration. They'll give you the mass. Note that. They'll give you the distance. But for you to calculate what? The acceleration. So the acceleration, this is what you need for the acceleration. Number one, we have, if it is, they're talking about inclined what plane? They're talking about inclined plane, two ways in which a body can move. Whether down the plane or what? Up the plane. Acceleration down the plane. Do you understand? So we have what they have g into bracket sin theta minus the coefficient of friction cos theta. So why the acceleration up the plane? So that's going to be plus. What is going to be the acceleration if the surface were to be a smooth surface? Do you understand? Or a frictionless? Do you understand? So a frictionless surface. So acceleration will be equal to what you have. So your mu is going to be equal to 0, and your acceleration is equal to g sine what? Theta. Now the last one is called what's work done against frictions? Work done against friction is force times distance. What's our acceleration? So we've explained that. So if we come here, we just explain what when the body is in motion. Actually, what the coefficient of friction, your coefficient of kinetic friction come into play when the body is in what? When the body is in motion. So for the body to stop the motion, the force to stop the motion is called what the coefficient of kinetic friction. So now because so mx is equal to coefficient of kinetic friction, and we get the acceleration because so what we have a s equals to what we have a coefficient of kinetic friction and what g. So this is called what? The stopping of the block due to friction. The stopping of the block due to friction can be asked, calculate the kinetic friction. So the kinetic friction, just pick up the formula. You don't need all this one, but the purpose of this, you might need it later. So coefficient, so stopping of the friction due to friction. So the coefficient of friction, you get this. But to momentum, if they link it to momentum, you get this. Now it's going to be what your work done, not the acceleration. Just put the acceleration inside that. Distance and time, you can calculate the distance. So if I ask you what the distance and time, so they'll give you the time. Look for the distance. So if it's not going to be what an inclined plane, so what's going to be the acceleration? That's why acceleration is very important. So acceleration down the inclined plane, you use this. Do you understand? For the acceleration of that is clear, and that's it. So don't forget if it's a rough surface, note what the acceleration is. If it's going to be a smooth surface, this is going to be what your acceleration. So next class we shall be talking about connected bodies and what and pulley system. So connected bodies, like if mass are being connected, what's going to be the force acting on them? And if for a pulley system, so how do you also treat pulley system? That is also very, very simple. See us, don't forget to follow us, and there's what? There's more. Thank you very much. Note, for you to know physics, last lecture the word cap. So what mean of cap means? Calculation, for you to understand calculation, you need to know the application. So that mean of what? Cap. C-A-P. For you to be able to know what calculation in physics, what is very essential is for you to know what we have, is for you to know the application. So if you know the application, will lead to what? To article. What's not P? See us in our next class. I'll tell you what it is.